Webcast is now starting. All attendees are in listen-only mode.
Well, good morning. This is Salim Khan with the Texas Energy Engineering Services, and with me is Bob Tonhoff with Tonhoff Consulting Engineering, and we will be jointly presenting today's webinar, which is for planning for municipal water and wastewater energy efficiency projects. I will give everyone a minute. I think there's still a couple of people trying to sign up. So we'll give them a quick 30 seconds or so, and then we'll start the webinar. Thank you. All right, we'll get started. I think people have joined in and signed up, so we can get going over here, and we'll do our best to finish within the timeline. I think it'll go pretty smoothly. I'll start up by doing a little introduction to the SECO program under which we are doing this webinar. So this is the State Energy Conservation, which is a division of Texas Comptroller of Public Accounts Office under there. The Schools and Local Government Program is the one that provides energy assessments, engineering technical assistance to schools, local government, mainly public entities across Texas. And then SECO has a program called the Lone Star Program, which provides funding source for energy and water conservation projects. The topic of today's presentation is just going over and planning for water and wastewater energy projects. And this is typically done under the local government energy program, which is a free service available to public entities across Texas. Before we dig too much into the nitty-gritty, I just wanted to give you all an overview of the type of energy audits that are available. Just want everyone to be familiar with those. So one of the type of energy audits called preliminary energy assessment, PEA. There are other names for it. They're called preliminary energy audit, initial energy audit or survey, or walkthrough survey and assessments. This is typically done mostly at no cost, and if you have joined or if you've requested the State Energy Conservation Office, this is the audit that you're going to get at no cost. It is a pretty good tool. It gives you some initial information that you need to kind of screen the projects. If you decide to do funding for those projects, in most cases, you'll be asked to do a detailed energy analysis. It's also called comprehensive energy analysis. In the ESCO world, it's called investment grade audit. And in the Lone Star, SECO Lone Star program, it's called utility assessment report. So that's more of a detailed audit in which cost and savings and all the assumptions are supposed to be outlined. The preliminary energy assessment is a quick walkthrough and then a screening process in which you can screen. You still have the cost and saving estimate basically for the projects. So just wanted to make sure that these two type of energy audits that are available out there that we are all pretty clear about. The SECO Technical Assistance Program for facilities planning and energy assessment, you get preliminary energy assessment, which involves a site survey, utility baseline development. It will identify low cost and no cost measures for you, and it will give you the cost and payback of potential energy and water conservation projects. And in cases where there's a need to develop an energy management plan, it will give you that information also. It will be all part of the report that will be delivered to you all. The PEA is a very valuable planning tool. And as I mentioned earlier, that it gives you a pretty good idea what is the potential of projects that you might have and what are their estimated cost and savings. Eligibility, any public entity is eligible for this service from SECO. So it could be local government, school district, county hospitals, port authorities, major airports, public water authorities, and municipally owned utilities. So pretty much this service is available at no cost, and it's an engineering services that is available at no cost to anybody who requests for it. The process in the PEA, which is a preliminary energy assessment, is that you request a service from SECO, and I'll share at the end of this presentation. It's a one-page simple document. We'll have some discussion and come up with the potential scope, which is called the need assessment phase. Then we will be requesting some utility data and site data. The utility data usually comes from the utility service provider, and the site data, the engineers will contact you all to look at, arrange for a site survey, which could be 1 day and could be for over 2 days, but that all arranged with you all to gather the initial data that's needed for analysis. Then in the office, analysis are conducted. Some energy performance baselines are developed, which is called the Energy Utilization Index and Energy Cost Index. Then quantification of the measures will be done, cost and savings and payback estimate will be created. And in the fifth step, we'll develop a report which will have baseline, which will have potential O&M measures, which are low-cost measures that you could implement without spending too much money. And then we'll have utility cost reduction measures with cost saving and payback estimate. It might also include energy management plan, and it will go over potential funding options for you all. And then at the sixth stage, or a step 6, the PEA report presentation, we will present the report of findings, provide recommendation for action items. So usually this takes anywhere from 30 to 90 days. It depends on how soon the site visits and data, especially the utility data, could be received. So overall, this is the process of PEA in which you get a pretty good engineering report that kind of outlines the potential of the projects. Wanted to go over two very important indices that are used, and they are also used for buildings, but also for water wastewater facilities. One of them is called Energy Use Index, which is annual energy use divided by average effluent flow, and that is in BTUs per gallon per day per year. And then on the Energy Cost Index, is the annual energy cost divided by average effluent flow, which is dollars per MGD per year, basically. So typically, these are the two indices that will be developed if you are in a water wastewater. If you have facilities included in the PEA also, it will develop the similar indices for the facilities also. For the water wastewater plants, it is not very easy to compare one water wastewater plant with another wastewater and wastewater plant. And there are many factors that influence the EUI and ECI for the water wastewater plants, such as the flow, the type of treatment system you have, and many other factors that affect that. So if you're comparing one water wastewater treatment plant to another one, then we need to look into some more factors to normalize this thing. But in most cases, you can have a raw energy use index and energy cost index developed, and then going forward, you could track your performance basically based on these indices, and just for your facilities. In the report, you will have these are the indices that we presented in graphic form, so you can see which plants are spending how much energy and what are they costing you. So this is just a graphical representation of the EUI and ECI that will be in the report for your facilities. Typical technical assistance examples would involve, we might do a thermal scan and then find out that there's a leak. You have a small air conditioning system at your facility, and then What you see over there is that there might be a slight leak on the roof, basically, so cold air is blowing out. And we will be taking inventory of your old equipment. And the reason for that is that we want to have a pretty good feel for what is the baseline of your equipment, so that when we are providing recommendations, we can look into the energy efficiency jump from the baseline equipment to what is being recommended. So this is usually a site survey, basically. So we look at the plant operations and do the visual inspections. Sometimes the plants may have more than 1 meter. This also applies for if you are a facility that has got multiple meters, then it is important that we will try to identify which meter is serving which area, so that we can do an accurate baseline development for those things. And these are the kind of things that are kind of covered in the site survey phase, basically, as we go through that. Typical measures and paybacks that you will see in a water wastewater facilities. Now, it's important to keep in mind that you might have measures that are within these payback periods, but you also might have measures that may be beyond or less than the payback period identified over here. Primarily, the preliminary energy assessment is done so that you can have a fairly good idea of what potential payback that is specific to your location. So, for example, water wastewater related O&M measures, which is operation and maintenance measures that we identify, and those will have a payback of less than 1 year. For dissolved oxygen control, they may be 2 to 7 years. For high efficiency blowers, anywhere 8 to 12 years. Variable speed drives, 8 to 15 years. Optimization, aeration design, 5 to 10 years. Power factor improvements, 3 to 8 years. Smart meter application. Now, this is on the water side. Could have a payback from 5 to 8 years. So in this PEA, we also look at if there's a request to review meter application or smart meter application throughout the city. So we look at that aspect of it also. And then city main leak sensing technology evaluation, it could have from 1 to 10 years. And water wastewater demand response program, that could vary basically depending on existing load profile and capital use for automation. So the key thing over here is that you will have a wide range of paybacks, and as a result of the PEA, we will be able to kind of narrow that down some. And the payback ranges are different because the assumptions or how you operate your facility has an impact on it. The rate structure has impact on it, and then the potential cost of those measures have impact on the payback. So the PEA will actually go through that process and kind of narrow that down for you. Well, over here, what I'm going to do is that I'm going to pass it on to Bob Tonhoff to go over some of the typical measures and analysis on the water and wastewater side. Go ahead, Bob.
Well, good morning, everyone. This is Bob Tonhoff. I've been working with TEESI for over 30 years, and typically I do the on-site investigation of the water and wastewater plants. And some of the things I like to look at while we're analyzing your systems is some of the things in these next slides. One of the first things I look at is your water pumping and determine how many pressure planes you have in your system. And I always like to recommend a pump to the lowest pressure plane first. I've seen cities that mistakenly pump to the highest pressure plane first and let everything flow down to the lower pressure planes, and that sure can waste a lot of energy. So a typical energy cost is about $15,000 per MGD per year per every 100 feet of elevation you have to pump. Next. Next thing I like to look at is pumping during your off-peak energy demand periods. We utilize the excess elevated storage capacity during the energy demand period, so you don't have to pump water to it. Also, we could utilize variable frequency drive pumping so that you do not have the the peak horsepower consumption during that period. And we found that we can save about 25% of the cost of pumping during the energy demand periods, or about $4,000 per MGD per year. For water treatment, we look at the utilization of high efficient pumps and motors. We look at utilization of variable frequency drives for motors that operate over a range of flows and have to turn on and off. We look at optimizing the plant's hydraulic profile so that you don't have little intermittent pump stations within your plant. And we look at your cost of chemical and compare the cost of chemical to the cost of energy to see if there's any relationships that we can see in your operation and maintenance. In your wastewater pumping and treatment, we look at the similar things too. We look at using energy efficient pumps and motors. Your typical most efficient energy pump in wastewater is about 70%, and your typical maximum efficiency motor is 90%. In wastewater, your typical worst case pump is around 40%, and your typical worst case motor is about 85%. So we found that you can save about 10% of your annual consumption by using energy efficient pumps and motors. Also, we look at using variable frequency drives. We like to recommend for any motor over 50 horsepower that you have a VFD or a soft start. I've been in plants that use 1,500 horsepower motors that were starting across the line. And when you have a energy demand charge, that will be a high cost. So we look at potential energy savings, and we estimate this about 25% of the cost of your pumping during a demand period, which could be estimated at $3,400 per MGD per year. In wastewater, we look at your use of gravity flow systems, and we recommend using them wherever possible. We found that a lot of developers that go into cities don't like to use gravity flow. They like to pump because gravity flow is more expensive than pressure systems, and it ends up costing the city a lot of energy dollars over the year. So we estimate your potential energy savings at $10,000 per MGD per year for every 30 feet of head that you have to pump. When we're at your wastewater treatment plant, we look at your hydraulic profile to make sure that it is optimized. We look at your aeration facilities and make sure that it is optimized and used to its best advantage. We like to recommend natural treatment processes that don't use energy. They just use nature, and that the plants that can use nature are the most efficient. We compare your cost of chemicals to the cost of power and try to see where we can save dollars. And we like to control your dissolved oxygen rate in your aeration. We found that anytime you're over 2, even over 1, you're often wasting money on power because your biological treatment process can often work very well in the 1 milligram per liter dissolved oxygen range. We like to look at your plants to make sure you're only pumping your wastewater once. You're pumping into your aeration basin, and then everything flows by gravity to your discharge. Potential energy savings, if this is not happening, this costs you about $3,000 per MGD per year per every 10 foot of head that is wasted. When we're looking at the aeration process, this is a chart that compares the type of aeration to the type of savings. And these are direct dollars. So you can see if you're using coarse air bubble aeration, it has a transfer rate of 1.5 pounds O2 per horsepower hour. compared to fine bubble, which is 3.3 or more than twice as good, compared to mechanical aeration, which has a transfer rate of 3.9, which is better than fine bubble. And we're now seeing these turbo blowers with fine bubble aeration that are ending up very efficient and can be have transfer rates estimated at 6.6 pounds O2 per horsepower hour. So it is very easy to save power by your method of aeration. And that is normally the highest energy cost of a wastewater treatment plant. Next. So coarse bubble aeration this is just a picture of a typical coarse bubble plant. It has large bubbles and large splashes. This is compared to a fine bubble aeration plant. You have fine bubbles and very little splashes, and it's much more efficient. Here's just a close-up photo of a fine bubble versus a coarse bubble. Here's a photograph of a wastewater plant that uses mechanical surface aeration. People are getting away from this, but it's still a very efficient process. And these mechanical aerators, I have them in service for, at one plant, 30 years. And they are just built to last a long time. Some of your natural wastewater treatment plants that people are getting away from, but they are still very efficient, are your facultative lagoons. If you can meet permit and utilize that, we're finding that you can save approximately 70% of the electrical cost. Your trickling filters are very efficient. They're about 65% of your annual consumption. When you have a biological treatment process that you could utilize anoxic zones for denitrification, you can save about 10% of your annual consumption just on this. So one of the most efficient plants that I have run across was a trickling filter plant. And that plant caught my attention because it was meeting a BOD of less than 5 and treating for ammonia nitrogen. And I really quizzed the operator how he can operate it with such efficiency. And I found out the trick was that they recirculated 100% of the flow back to the primary clarifier. And when they did that, they achieved nitrification and low BOD rates. And that's not in the textbook on a trickling filter. So that is something that I learned in my career. And one of these days, I might have an opportunity to design a trickling filter plant that is very, very efficient. Some of the TCEQ criteria that we look at is when you're designing a wastewater treatment plant, you have to design it so that you can maintain a 2 milligram per liter or part per million of dissolved oxygen. And we've found over the years that the process can operate efficiently from 0.5 to 1 milligram per liter. So that extra amount of O2 that you have can be summarized in the general statement saying anything over 1 part per million is wasting power. You have a potential energy savings of about $1,000 per MGD per year per milligram per liter of DO. So if you're operating your wastewater treatment plant over 2, and I've seen some operate at 4 or 5 parts per million, you're wasting $1,000 per MGD per year. So just keep that in mind. You don't have to run it at a high level to maintain treatment. One of the other things that we've noticed over the years is ultraviolet disinfection is very cost effective when compared to chlorination, dechlorination. We've found that it can pay for itself in a 7-year period from the cost of chemicals versus the cost of power. So ultraviolet disinfection is not only a good disinfection method, it is a cost-effective disinfection method. Some of the things that can really save a lot of money and conservation and power in a city is fixing water leaks. These advanced metering systems that can detect water leaks are so energy efficient, they can pay for themselves very, very quickly when utilized. They can be used for water leak detection. They can be used for automated meter reading, and you can greatly reduce your unaccounted for water loss in your water distribution system. So on the wastewater side, we are recommending implementing a infiltration and inflow analysis that can identify your stormwater infiltration, and this will mitigate your wastewater pumping and treatment. And we found some cities have I&I as high as 20% easily, and some have inundated themselves 100%, 200%, 300% over the years. But when you can identify your stormwater infiltration and inflow, you do not have to pump that water. You can mitigate it, and you don't have to treat it. So just keep in mind, just a simple I&I study can save lots of money and lots of power. Finally, in our analysis, we look at cost of disposal versus cost of treatment of sludge. And landfill cost of disposal is very, very expensive nowadays. And it sits in the landfill forever once it's there. You do have an option of your sludge to beneficially reuse that sludge and grow crops and create an income for that sludge. So it's a lot of work to reuse sludge, but it does pay for itself over the years. So keep in mind when you're looking at landfill costs, you can do some agriculture and have beneficial reuse that will pay back relatively quickly.
Thank you, Bob. I'll circle back to the PEA process, basically. What I wanted to do was give you all a brief an outlook of what a report under this program would look like. There'll be an executive summary, and the table of contents will have facility description. We have energy consumption and performance. We'll have an Energy Star portfolio manager information, and excuse me, Energy Star portfolio manager is collecting data and on the water and wastewater sides. I've seen very few certifications for those, but that's something that's available, and we'll have some information on that. It will go over the energy accounting and utility rate analysis that you're paying, any legislative updates as regards to energy related subject matters. It will have recommendations of operation and maintenance procedures. It will have utility cost reduction measures. Now, this section is the one that will have potential projects. These are capital projects that will need some sort of funding, basically. So it will have the potential cost, the potential savings, and the payback for those projects. And you will have all that information in this section of the report. And section 10 of the report, we'll have an energy management policy, some information on that. And there have been cities and counties that have tried to implement water and wastewater energy management plans. So we'll have some information on that. We'll have some information also on the Lone Star funding for utility cost reduction measures. This is the SECO program that provides low-cost money to public entities to fund their energy and water conservation program. And there will be additional funding options outlined in this report if there were any grants available at the time, or, for example, Texas Water Development Board information is available. So that will be shared with you all. So this will be a report format that you will see after you have requested it and analysis have been done. And then we deliver this report that will have those contents. And the appendices of this report, you will have all the backup information, especially the utility consumption history, the energy performance comparison chart. Well, this is the Appendix C is one that we started doing around about 10, 15 years ago in our office, in which we have taken raw data from a lot of plants that we have done audits on in Texas, and then we start comparing them, and we developed a little chart. That way we can say where your consumption or performance compared to the rest of them, the data on Texas that we have on them. So it's a good raw comparison for raw comparison purposes. Typical equipment maintenance list will be provided, the Lone Star information, the building commissioning information. So we're calling it building commissioning information, but more and more the commissioning and optimization of water and wastewater treatment plants is also becoming pretty popular and common, and that's actually one of the potential opportunity that we might be looking at when we're doing the analysis. And then some information on Energy Star Portfolio Manager. Well, with this, what I'd like to do is give you some case studies of various cities across Texas that have participated in this program, and then give you all a little overview of what was the potential that was identified and what type of projects they had. So this first one is New Braunfels Utilities, which is between Austin and San Antonio, close to San Antonio. We identified close to $9.7 million of projects, and they had a payback of 6.6 years with estimated utility savings of around about 1.47 million per year. And this was mostly, majority of it was from water and wastewater plant analysis. The biggest portion of this project was that we identified codes to find bubble diffusion, install water wastewater treatment dissolved oxygen sensors, install high efficiency variable speed drive turbo blowers on their water wastewater plants. But the majority of the project is where we looked at, they have over thousands of 5/8 meters for the residential sector, and they wanted to do an analysis of what would it cost and what the potential savings are if they do a meter change out, which was to this automatic meter reading and integration of that into their overall system. So that study with some statistical analysis, and they also provided us their utility meter data, and based on that, almost 70 or 80% of this project was specifically geared towards doing those analysis. So the next step was that they did a small prototype, and then round about, I think they've completed most of this work now, especially on the meter change out. But they started a prototype project and then expanded that throughout the city. So a lot of their meters, especially at the residential side of it, have the meter change out over there. So that was primarily as a result of doing this PEA and participating in this program. And then from there onward, I think they had integrated it with a third-party service provider that was a performance kind of a contract, basically, in which case they updated some of those meters. And this gave them at least an independent view of what the potentials could be, so they could compare to what they were given by the vendors. So that was another reason they participated in this program. Pretty successful, what I've been told. This is another case study in which a city of Pharr in South Texas, basically $1.4 million projects were identified with a payback of 1.3 years and estimated savings of $1 million per year. with a lot of water savings you can see over there. And primarily, this was a dissolved oxygen control systems, high efficiency blowers, variable frequency drives, and again, application of leak sensing technology over there. So one thing I just want to clear it up, and Bob, you're more than welcome to jump in. When we're talking about the leak sensing technology, one way to look at it is that the cities have distribution systems, basically pipes that go out throughout the city, and sometimes there are leaks in those distribution systems. So those are something all the cities, I believe, are required to do a leak study every year or every 2 years, and that tells them roughly how much of their water they're losing in the process from the generation to the end point, basically.
That is correct, and I'll talk in general numbers again. Typically, when we're over 5% unaccounted, we're considered to have a problem. And now with this leak sensing technology, these meters can detect a water leak by hearing it and triangulating it between the leak sensors of the meters, and you can get within 10 feet of where your water leak is, just by your computers analyzing the triangulation of the leak sensing technology. So that's a pretty slick way of finding a leak. And now these systems that are gaining this leak sensing technology are getting well under the 5% level and hitting the 2% level or less. So particularly if you're a city that has an unaccounted for water rate of in the 20 percentile, this leak sensing technology will really save a lot of money quickly.
So the other thing is that you can also see a leak if there's a puddle of water, I guess, so that's another way to look at these things. But anyway, technology is advancing and it is available, and it could be utilized over there. The other case study over here is the city of San Marcos. They had done a preliminary energy assessment, and then at that point in time, they had received a notice that they have received a DOE grant. As a result of that, they used some of that grant money to do a couple of their projects, but at the same time, they used that grant money to fund detailed energy assessment of all their facilities, including water and wastewater facilities. And as a result of that, they wanted to pursue the SECO Lone Star program. So the projects that were identified were close to $1.9 or $2 million with annual saving of $220,000 per year with a simple payback of 8.9 years. And the type of projects that they implemented were lighting retrofits with motion sensors, HVAC replacements, control upgrades and retrofits of their HVAC systems, looking at solar thermal pool and water conservation measures, and most importantly, at their wastewater treatment plant, replace blower and automatic aeration airflow system. And that project was done, and most recently we've been notified that they had a couple of other blowers at that facility because this blower system and the control was so successful that they have, from their own funds, decided to upgrade the remaining blowers at the facility also. So that's an example of city of San Marcos over there. This is another example in the city of Laredo. They had done a preliminary energy assessment where the projects identified were $7.5 million. This assessment was specifically for their utilities department with an annual savings of $1.7 million and simple payback of 4.2. Mostly it had water leaking technologies and so forth, but at the same time, there were some VFDs installed over there. After the PEA, they looked at their options. They funded some of their projects, especially on the meter upgradation and so forth from their own funds. They had some plans for it, but then at the same time they went to State Energy Conservation Office to ask for one or close to $1 million with an annual saving of $159,000 a year with a simple payback of 6.5. And in that project, the primary funding went to high service pump VFDs and power factor correction. So these are VFDs that are not rated at your 460, but they're at 12 kVA, range basically, which is very, these VFDs are the size of a room basically. These are not the VFDs that you typically will see on an HVAC system or a small systems. Basically, the pumps are 300-400 horsepower and they require a pretty large size VFD that uses high service pump VFDs. So that project had two benefits basically. First of all, it went into the energy aspect of it and had some energy savings, but at the same time, they were able to control some of their flows because they realized they were overflowing and to certain areas, and as a result of this, they were losing some water from the tanks and so forth. When they were doing the storage, they were able to control that aspect of it also.
Yeah, let me jump in here. It was just a real interesting case where Laredo's minimum size high service pump was too much flow during their low usage period of the evening, which is like from midnight to 4 a.m. So it was filling up the water tank and overflowing. And we recommended putting a VFD on it so that their minimum size pump can pump, at 50% of what its max capacity was. So anyway, they were able to do that, and that completely solved the problem real quick. They solved their water leak and saved money.
Thank you. As a result of that, they currently are considering some more projects, again, VFDs and motor changeouts, and they're doing it with another source of funding. A performance contract is involved in that aspect of it. But that just gives you, these case studies kind of give you a good overview of how people have utilized the service to identify potential projects, and basically from there onward, they all have, come up with their own way of looking at what they can do to upgrade and to fund these projects. This program does not mandate that you implement the measures that have been recommended to you, but it does expect that we will look into what options are available, and it just needs a commitment primarily from the end user or the city or the county, basically, to make sure that they look into ways to implement the measures that were identified in these PEAs. So something to keep in mind, the benefits of doing a preliminary energy assessment or initial energy assessment is that it's a very valuable planning tool. As I mentioned, it kind of gives you one of the basic information. People have taken that information and then decided that they need to put some of those projects into their capital annual funding. Some they want to fund it through maintenance and operations. And some projects they've decided to fund it from SECO or Texas Water Development Board or some other source of funding. So again, a very valuable planning tool. It gives you some basic information that you need to plan for future upgrades and so on. It will also develop a baseline energy use for you. So baseline energy use is very important because going forward, if you do some of these measures, you can track your energy over a period of time and compare it to your baseline. So once you've established the baseline, you do some projects or you implement some projects, and then you can track them how you were doing. So that's something, at least the baseline development will be done over here. You can prioritize your investment, as I mentioned. So what are the costs and paybacks will be provided? You can decide we want to do certain project this year and few projects next year because everybody doesn't have unlimited funds. And also, you never know when you do some of these PEAs, there might be an opportunity for grant funding and so forth that might become available. So you can use some of the information that would be needed to apply for those grants if you have done this PEA. Again, some low cost, no cost measures are identified, and these are typical measures that will have almost no cost associated with it. And we'll be recommending some of those if we see there's an opportunity for it, basically. This PEA is also a source of technical assistance. From time to time, we have been asked to look at, for example, they were considering a new design for their treatment facilities or wastewater plants, requested that we look at least from energy efficiency point of view and provide some input and guidance on that. So that has been done. In certain cases, they might have had a specific issue that they want to address, and that issue was indirectly had an impact on the energy savings part of it. So we were able to provide some feedback on that, and it is a roadmap to utility cost savings. So this PEA would be a roadmap to utility cost savings, and again, as I mentioned earlier, that it will also identify potential funding options for you. One thing to keep in mind is that the SECO program is not a design. It doesn't get into the design aspects of these projects. It will give you the assessment and preliminary cost and savings estimate, but for design and implementation, you all have to use your sources basically for that. Now, in the SECO Lone Star program, those soft costs for future design and construction can be included in that Lone Star funding or loan program, which is they provide interest at 1% and 2% available to do these energy efficiency projects. So, in a nutshell, you will see that you have a lot of benefits of doing this PEA. And if you have included your buildings, it covers those also. If you've got water and wastewater facilities, it covers those facilities also. A lot of time we have limited funding, so you may have a number of facilities that you want to look at, but we are only able to look at certain facilities because we're trying to spread the funds available for this aspect of the program across the state of Texas. So in that case, that's where when we are talking about need assessment, we go and prioritize those areas that are plans that we need to look at, and that will be the general scope of the project, basically. Well, how do you participate in the SECO program? Very simple process. On the right side is the application that you see. Basically, it is your contact information. You put all that information over there. There are a couple of questions that you answer, and principal agreement is mostly saying that you will take steps to closely look at the recommendations over there, and you sign in and you turn it either to the State Energy Conservation Office or the Engineer Office, and they'll turn it to the State Energy Conservation Office. Ideally, you send it to the SECO office and they'll distribute it. They've got a couple of engineering firms working on that, and we are just one of them. So the best way to get this information is you visit the SECO website and fill out the request form, and this is the hyperlink available to that. You can also contact LaShawn Menace or Salim Khan, which is me, if you have any questions. And again, the contact information for the State Energy Office, Energy Conservation Office is provided over there, and then you can contact them directly. With this, I think we might be a few minutes early, but we have left some time to kind of go over if there are any questions that you all might have. and we can go over any questions and answer if you all have any questions. You can put those in the chat over there, and then we can potentially look at them and answer those questions if you all have it. So, and with this, I will just let you all think about if you all have any specific questions on the program that you'd like to answer. And we will also we can unmute. So I think we have unmuted the participants. So if anybody has want to have a direct question, they can ask to Rohit. Bob, do you have any specifics that you want to just kind of emphasize, basically that could be beneficial?
I think two of the main things that save the most money in a energy efficient analysis is the type of aeration system you use at your wastewater plant. That's the number one, and we try to upgrade to the more efficient methods of aeration. And for your water system, the most efficient thing we've been finding is this leak sensing technology that can find your water leaks and save you the cost of pumping and treating water that is leaked into the environment. So overall, those are your two best methods of conserving and saving.
Yeah, and also just want to make sure that everyone is kind of aware of it, is that the SECO program is a free engineering service for the initial analysis part of it. And SECO has some programs planned down the line, basically that might be some grant fundings and so on and so forth as the ERA funds come through. The Lone Star program is pretty active. It is open. You can apply on first come first serve basis, and then you can apply on first come first serve basis. They also have simplified the application process a little bit, in which it's a 3-4 page application process. It needs some basic information. You can put all that stuff in. But if you have done a PEA, then you will have that information, whether you're kind of applying for any potential grants that may be coming, block grants that may be coming, or you want to apply for the Lone Star program. So the PEA will actually provide you all that basic information over there, basically. Sometimes we are asked to do some much more deep analysis on certain aspects of the things. Again, the SECO program, this program is not for the design aspects or getting into those aspects of it. It does allow for a review from energy point of view. So if you got some plans developed and you want to look at it from just a quick review to make sure that overall general principles are being followed, basically for the energy efficiency in your future plan designs. Those are the kind of things that could be covered under the program. But again, since we have limited funds and we are trying to reach out to a lot of people, the main goal of this program is to provide PEA services, which is the information that most of the people actually request and are asking to look into that. So other than that, I think if we don't have any specific, now again, you all are more than welcome to reach out even after this. The emails are there, and I think we will be sending the PDF of this presentation and potentially also the video recording of this presentation, so that'll be available for you. I think it'll be automatically sent from the webinar system that we have. And if you all have any questions afterwards, you're more than welcome to contact us, basically, and we'll try our best to answer those things. So with that, if there are no specific questions, we might end up a few minutes early, if that's okay. I think it's a good thing. So with that, it looks like there are no other specific questions. So what we would like to do is we like to end the seminar, and I'd like to thank everyone that have participated in this seminar. Also want to let you know there is another seminar this afternoon which will go into the commissioning process. That is mostly for the buildings. And tomorrow we have two webinars basically that goes into the DOE energy efficiency savings upgrades that are required in 2023 for the HVAC systems, and the analysis, and the other seminar tomorrow is on the analysis of a PV system, photovoltaic system application, basically. So those are tomorrow and the one this afternoon. Hopefully you all could look into joining on those. And that's all I have. And I think Bob, thank you for joining in from myself and Bob. And this third person that joined in the end was Joey Pham. He's actually helping us do some administrative stuff on this webinar system. So thank you all. Look forward to hopefully hearing from you. If you all have any specific question with this, I'd like to end the seminar. Thank you.